Alright, now we're going to start learning about rational functions. So here are our learning targets for today. I can simplify rational expressions, I can state any restrictions on the domain of a rational expression, and then I can multiply and divide rational expressions and state any restrictions. So let's look at first what a rational function is. A rational function can be written as f of x equals p of x over q of x. Right? So p of x and q of x are polynomial functions. Remember we talked about polynomials a while ago. They're just several terms. The domain, right, my domain remembers all x values, is all real numbers except for those values that make my q of x, my denominator, 0. And just because remember we can never divide by 0. So I have to look out for anything that would make that happen. So we're looking at simplifying. So a rational expression is in simplest form when the numerator and denominator have no common divisors. So here are some examples. This first one is in simplest form because there's nothing that I can divide out of both the top and the bottom. You'll see that I have an x in both the top and the bottom, but I can't do anything with it because this is adding or subtracting down in the denominator, so that means I have to leave it alone. These examples are not in simplest form. Here you'll see I have an x in the numerator and x squared in the denominator, and those I know I can simplify. This one also can be simplified because I've got a 2 and a 3 out front, and these two terms, this x minus 3 and the x minus 3, are the same, so I can simplify those out. So these are not in simplest form. So let's look at an example. I'm asked to simplify x squared plus 10x plus 25 over x squared plus 9x plus 20, and then state any restrictions. So the first step I want to do is I want to factor my polynomials. Right? And so my numerator factors into x plus 5 times x plus 5. And I know that if I was to distribute this out, this is what I would get, so I can double check. And my denominator factors into x plus 4 and x plus 5. So then I can factor out the common factors. So I see I have an x plus 5 in the numerator and an x plus 5 in the denominator, so those can go away. So my final solution is x plus 5 over x plus 4. But I know that my restrictions, I cannot have x be a negative 4 or a negative 5. Because if my x is negative 4, this part of my denominator becomes 0, which makes the whole denominator 0. And if x is negative 5, this part of the denominator becomes 0, which makes the whole denominator 0. So those two values cannot happen. So my final answer is my simplified expression is x plus 5 over x plus 4, for x cannot equal negative 4 or negative 5. And those are my restrictions. So let's look at another example. Okay, so one factor in designing a structure is the need to maximize the volume, which is the space we're working for a given surface area. So we're going to compare the ratio of the volume to the surface area of a cylinder with radius r and height r to a cylinder with radius r and height 2r. So here's my volume and surface area formulas. So I want to compare volume over surface area. So I just write my volume over surface area, right, and volume over surface area. So I know that h I was given for both of my cylinders. In my first one, my height was given as r, and my second one, my height was given as 2r. So I simplify, I substitute where that h was, and I put in r for both of those, and then I can continue to substitute and simplify. So once I get to this point, I notice some things that are common, right? I have 2 pi r squared and 2 pi r squared, which gives me a total of 4 pi r squareds. Here I have 4 pi r squared plus 2 pi r squared, which gives me 6 pi r squareds. Now I can combine like terms and simplify. So I notice in this first one there's a pi in the numerator and a pi in the denominator, so those can cancel out. I see that I have 3 r's in the numerator and 2 in the denominator. So that means I have 1 left in the numerator, and that's as simple as I can get that one. Over here I do the same thing. Pi in the numerator, pi in the denominator, 3 r's in the numerator, 2 r's in the denominator, those can simplify, and then 2 over 6 I know is the same thing as 1 over 3. So here are my given ratios that I was supposed to find for that. So when we're multiplying and dividing, we have to take what we've done with simplifying and add that in. So I'm asked to multiply this 2x squared plus 7x plus 3 over x minus 4 and x squared minus 16 divided by x squared plus 8x plus 15, and then state any restrictions. So the first thing I want to do is I want to factor every little piece of my equation, right? So this first polynomial becomes 2x plus 1 times x plus 3. divided by x minus 4. This can't really be simplified at all or factored out, so I just leave that alone. And my second term becomes x minus 4 times x plus 4 over x plus 3 times x plus 5. So now before I go any further, before I do any multiplying, I want to divide out the common factors. So I see I have an x minus 4 in the numerator and an x minus 4 in the denominator, so those can cancel out. And I have this x plus 3 in both the numerator and denominator, so those cancel out. So I'm left with the 2x minus 1, the x plus 4, and the x plus 5. So that's where this is. So then that's just my product. And I can leave it like this. I don't have to actually multiply it out. But then I can go back up to my original part, right, my very original equations before anything was canceled out, and I can come up with my restrictions. Okay, these are the restrictions right here. So I know that x cannot equal 4, because that would make this part 0. X cannot equal negative 3, and x cannot equal negative 5, because those values would all make the denominators 0, which I can't have. So here I want you to go ahead and try this one on your own. So we're going to multiply a squared minus 4 over a squared minus 1, and a plus 1 over a squared plus 2a. So don't forget to state any restrictions. So go ahead and multiply these two together. So we can also divide rational expressions. This is not nearly as difficult as it may seem. So I'm told to divide this first one by the second one and state any restrictions. Well, I know that I don't like dividing fractions by fractions, so all I have to do is multiply by the reciprocal. So my first one I leave alone in the same order, but instead of dividing, now I'm going to be multiplying, and I flip this other fraction upside down. So then, once I'm doing that, now we're back to just multiplying, which we just did. So then I can find any common factors in the numerator and denominator and cancel them out, and then I can just multiply straight across and rewrite. And then I have to remember all of my restrictions, and I have to look way back up at the very beginning to see my restrictions. Okay, so my x cannot equal negative 2/3, 2, 4, and y cannot equal 5/7, because I had this y over here, don't forget. So once I have that, I've gotten everything that I need to out of this. So here's the homework for you. There's some work problems in the book and then some Khan Academy skills. So let's look really quickly at our learning targets. I can simplify rational expressions. We did that several different times and when we multiplied and divide. I can state any restrictions on the domain of a rational expression, and remember that this has to happen from your very original equation. And then I can multiply and divide rational expressions and state any restrictions.